While you're getting your Chapter 10 review packets out and passing those up, have a little rhyme. Have you seen this one before? Maybe your Algebra 1 teacher showed it to you, no? Okay. Hey diddle diddle, the median is in the middle. So true, so true. Median is in the middle. You add and then divide for the mean. Yeah, if you haven't taken your Chapter 10 Chapter 10 test yet, you can keep these review packets. You need them to study. When you take your Chapter 10 test, if you're a person who still needs to make it up, make sure that Chapter 10 review packet comes with you. You can hand it in then. The mode is the one that appears the most. You might remember that. And the range is the difference in between. And when they say the difference in between, they mean between the highest and lowest data values. So to make it official, we have some vocabulary to kick off Chapter 11. The first set of vocabulary for today's lesson deals with measures of central tendency. In other words, numbers in the middle of your data set. Central tendency means in the center. So specifically, we mean mean, median, and mode. So go ahead and give you a second to copy down those definitions, and then we will talk about them. So again, these are measures in the middle of your data set. So now that you've copied down the vocabulary, we should probably talk a little bit about the goal for today's lesson. I'm thinking most of you have already done mean, median, mode, range, maybe even standard deviation. But we're going to use a calculator today to calculate those 5 measures. So if you're looking at the worksheet that you grabbed when you walked in and you're like, oh man, this is going to take a long time because I have to do all of these by hand, that's not a correct assumption. I'm going to show you how to do these things on a calculator today. Okay. So the first goal is to produce these data values on a calculator. Second goal for today is to throw in the definition of an outlier. You might recall a little bit about an outlier maybe from your Algebra 1 class. We're going to talk about an outlier and what that does to your measures of central tendency and your measures of dispersion. So what effect does it have? What effect does an outlier have on mean, median, mode, range, and standard deviation? So you'll see I left some blanks in your definitions for today. First of all, we have the definition for the term mean. It's the arithmetic average of all of your pieces of data. You know, if I had to calculate your class average on yesterday's test by hand, I would just add up all of your test scores, and then we got 23 in this class, but 3 didn't take it, so I'd add them up and divide by 20, because there'll be 20 people that took the test. And then in our calculator, however, we would enter our data, which I'm going to show you how to do today, and your calculator calls the mean X bar, X with a little hat on it. So when you're going through the outputs that your calculator is going to give you, X bar is the value associated with your mean. The median, like a median on a highway, is just in the middle of the road. A median is a middle value in an ordered set of data. So you have to put the data in order first and then find that middle value. I have a question for you though. What do you do if the data set has an even number of pieces of data? Do you remember how to find the median? Good, Bree. Yeah, you find the arithmetic average of the middle 2 pieces of data. So you just add those 2 middle values up and divide by 2. Some of you can also spatially reason out where the median would fall if there are 2 even numbers in between, or 2 numbers in between. You can also find your median that way as well. Your calculator, again, will be the major tool we use today to go over median, and your calculator will spit that out for you as MED. That's the calculator's abbreviation for median. And I always think mode has that long O sound, mode, and most frequently occurring piece of data. So the mode is the most frequently occurring piece of data. Now your calculator doesn't spit out a mode, but you're going to see today, we're going to gather data on you folks. And you're going to see that to find the mode for our class with maybe 20 pieces of data or so, to find the mode, just put your data in order, and then it's really easy to count how many there are of each piece of data. So it's nice. Just put your data in order. and you can find the mode pretty quickly. Next step, we have measures of dispersion. Root word, disperse, to spread it out. And the definition of our range is just the difference between the greatest and least data values. On a calculator, you know, your calculator doesn't say, hey, range is this. You actually usually have to do a little bit of work to find that. Your range, quite simply, is found by taking your max minus your min. So whatever your calculator outputs for the max, minus whatever your calculator outputs for the min. And the definition for standard deviation. Standard deviation is fancy talk for a typical difference. It's a value that describes the typical difference, or deviation, between a data value and the mean. So thinking back to your Chapter 10 test from yesterday, to calculate the standard deviation for our class, I would have to look at Calvin's test score and figure out how it relates to the mean, and then Ryan's test score and how it relates to the mean, and then Eric's test score, how it relates to the mean, and then Marissa's and how it relates to the mean, and then Ryan's, and then Sally's, and then Bree's, how all of yours relate to the mean, and then it's an average of that, more or less. More or less. I actually did do standard deviation out by hand one time with a class. It's long, it's not hard, it's just long. Your CHS Prob Stat teacher or your AP Stat teacher next year will show you how to do it out by hand. Honestly, there's two types too. Your calculator outputs two types, SX or Sigma X. And you're probably saying, well, which one do I use, Mrs. Lucas? Again, they'll get into it a little bit more next year. For the case here, you know, SX actually stands for a sample standard deviation, whereas this is said little sigma X. This is for data associated with a population of people. Your book uses this one the most. So if you're trying to check your answers in the back of the book, they're going to be referring to the value on your calculator that's next to the little sigma. However, some of the stats teachers produced materials for this chapter, and they use standard deviation appropriately. They don't just unilaterally use the sigma X. So sometimes you're going to see that they use the SX value. And to be quite honest with you, it's not within the scope of our course to get nitpicky about the differences. You're going to notice that the numbers are really close together. So if you want your answer to match the back of the book and you want to make sure you're punching in the numbers correctly, go ahead and use sigma X. That's what our book is going to use the most. Okay, so next up, we're going to do some examples of this. Do it on a calculator. So you got your calculator out? I'm going to show you. Okay, first of all, we need to collect some data, because my first major mission for today is to show you how to get all of this stuff on your calculator. The second objective for today, again, is just to observe how an outlier affects or doesn't affect some of these measures. All right, so you'll see here we're going to collect some data. I need to know, think of a number, of hours you spend watching TV each week. So take a minute, think about it. How many hours a week do you spend watching television? You got a number? We'll start with Heather. We're going to go up and down the rows. I need to know your number. You're going to want to write these numbers down too, just because we're going to toggle back and forth between screens and the numbers aren't always going to be up here. So write them down, that way you can type them into your calculator. All right, so Heather, how many hours a week do you watch television? Like 5? Heather D. 10? Vika. 9? Anna? 8. Adam, 9. Daniela? Joshua, what do you think? 3. 5. What do you think, Luke? 9. 6. Izzy? And 10. Ryan? 10. 9. What do you think, Calvin? 3. 9. I've gotten some crazy answers. You guys are pretty tame. I've gotten like 40. I do it as a full-time gig. Yeah. It's my job outside of school. I watch TV. I'm like, oh, okay, good. Oh, I don't know. I think I got 1 last period. Or first period, I should say. So, probably that's the lowest. You can't go negative, right? Okay, so now what we're going to do, I'm going to show you how to enter this into your calculator. I did give you a little, I typed out the keystrokes for you. So if you're trying to follow along and I get a little bit ahead of you, you can refer back to the paper or you can raise your hand. I will come around and help you out. And I need a very generous soul who was very conscientious about writing down our data values to nice and loudly read them off to me. Calvin, do you want to be that nice, kind soul? Oh, you're awesome. Okay, by the way, first, how I got here. Stat. Oh, yeah, because we're dealing with statistics. So stat is the button you're going to go to. It's right below your delete key. Stat. Edit. And right now your screen should say L1 at the top. If it doesn't, you can reset that. I can help you with that in a minute. If it doesn't say L1, that's going to change your input in a couple of steps. So stay tuned. Okay, go ahead, Calvin. We're ready for you.
5, 10, 9, 8, 9, 10, 10, 3, 8, 5, 9, 6, 6, 10, 10, 9,
Did I get both 10s? 10, 10, 9, yes. Okay.
10, 3, 10, 3, 9.
We have 21 people. Did I miss a 9? Right here. 9. There we go. So we're good now? How many people I have here today? Do I have 22, 4, 7? Yes. Okay. All right. So we've entered our data. Is everybody good? Everybody was able to enter it? Okay. All right, so now our goal is to get mean, median, mode, range, standard deviation. So 5 measures is what we're looking for our calculator right now. What is interesting is that the next set of buttons I give you doesn't produce the mode. So if you're given a big string of data like this and you need to find the most frequently occurring data value, you could try to count them up, you know, as they're all scattered, but it's a little easier to see if you sort the list. So what we're going to go ahead and do is I'm going to show you how to sort this list so it goes from smallest data values to largest. So what we're going to go ahead and do is we're going to quit. Go back to your home screen and you're going to press Stat and you'll see option 2 says Sort A. That's what you're going to choose. We're going to sort the list. And the list that you're going to sort, mine was L1. I entered my data into L1. If you didn't enter it into L1, you need to pick whatever list it was that you stored your data values under. I choose L1. You'll see it's blue and it's right above the 1 key. So I could press second and 1 and you see L1 appears in my parentheses. So it will sort that list. It's going to sort whatever you input into the set of parentheses there. And then you press enter and it says done. You're like, well, what's done? I didn't see a list appear there. That's because it actually sorted it in the list. So if I go back to stat and edit, you see my list is now in order. So take a look at your list. I want you to look at that list, and I need you to determine for me right now the mode of our data set. And you can see it's a little bit easier to do if the data is kind of arranged nicely for you. Okay, was anybody not able to sort their data while you folks are looking for the mode? Ooh, whoa. I'll have to find that list for you. So stat, sort. So it'll be under memory, and I'm going to guess it's under your lists. No. You're going to want to reset your lists, but that's going to delete this information.
I'll just type it back in.
You know, don't worry about it for this one. Don't worry about sorting it for this one. You'll, oh, no, you won't be able to do it. Let me make sure you can do the next step. Yeah, so it'll still do all the other stuff for you. You just can't sort it right now.
Correct.
Okay, anybody else not able to sort their list? I'll get your L1 back for you in just a minute, okay, Ryan? All right. What is the mode? Will help. What'd you get, Calvin? 10? Yeah, that was actually the mode in my period 1 class, too. Great minds think alike. Mode was 10. Okay, so now what we need to do is use our calculator to calculate the other measures. So the measures of central tendency that we have left, we still need the median and we still need the mean. And then we still need both measures of dispersion. So we still need the range and the standard deviation. So here's how that works. You're going to go to stat, arrow over to calc. And there was only one thing that was changing from student to student to student in the class. One variable. One thing changed, and that was the number of hours each of you watch TV per week. So really only one thing was changing, which means we're working with one variable statistic, single variable statistic. So you choose option 1. Boom. There it is. It's a lot of information. And there's even more. Do you see the down arrow? Don't press it yet, because once you scroll down, you can't come back up unless you have a newer calculator. But X bar, do you remember what that was from our vocabulary today? It's the mean. Very good. About 7.8 hours of TV is your average. Period 1 was 8. Wow. Anybody have any idea what the number 171 refers to? Sigma. Close. It's big sigma. Yep. Big sigma. Oh, you're going to see it a whole lot in a chapter or two, depending on when we throw in our sequence and series. It actually means sum. Sigma is a sum. Please remember that. It's not pertinent for this chapter, but in a few chapters it will be. Sigma x is the summation of our data. So 171. Square that number, you get 1,463. Sx and sigma x, we use sigma according to our textbook. We're looking at about 2.5 for our standard deviation. So you can record that in your notes. Your calculator just comes out and tells you what standard deviation is. I know it seems like a magic trick, but there is a formula associated with it. You can read about it in your book, or your CHS Prob Stat teacher next year will get a little bit more into where that comes from. What's up? Oh, that's a typo. The last one should be standard deviation. So find the range, and then the last question should say find the standard deviation. Yeah, and that is about 2.5, yes. You see that they're never far off. So if you rounded both to 2.5, you get the same answer. You know what n is? 22. Number of students who just took our survey on how many hours a week you watch TV. So n is your number of pieces of data. And then see the down arrow? That means there's more info below. Your min, which is necessary for calculating the range, is 3. Q1, do you remember doing box and whisker plots in Algebra 1 maybe? Yeah. That stands for your lower quartile or your first quartile. Quartile, fancy talk for a quarter, which means 25% of you, 25% of the 22 students in this room will watch between 3 and 6 hours of television. True story. Median, that's 9, which means that 50% of you will watch between 3 and 9 hours of television. I believe median is one of our measures of central tendency, so you do want to record that one in the appropriate spot in the notes. 25% of you watched between 6 and 9 hours of television. Q3, that's your upper quartile, which means that 25% of you watch between 9 and 10 hours of TV. And, well, hey, that's because our mode was 10. And then lastly, our max value, also 10. So we have this box and whisker plot that's missing a whisker. So yeah, now I have to calculate my range, right? Max minus min, 10 minus 3 is 7. What's up, Will? Yes. Questions about that? All right. Do you think you need practice entering it into your calculator? Is my question to you. Because we could actually probably get a little bit more practice and throw in the topic of an outlier, but if you guys seem okay. All right, we're going to try example 2, see how it goes. Before we get too far into example 2, this is our second objective for the day. Our other goal is to just sort of get you to be able to talk about how an outlier affects these measures of central tendency and these measures of dispersion. So first we have to define what an outlier is. Does anybody know what an outlier is? Have you ever heard that word before? Do you know, Calvin? Yeah, it's like an outsider. Outlier and outsider. Sort of. Perfect. Almost the textbook definition. Good job, Calvin. It is a piece of data not typical of a data set. Yesterday's test was pretty good. I didn't have any outliers. So that's usually a good sign. But let's say I had somebody in here who just didn't get it. Didn't, maybe none of the homework, had like no understanding of probability, permutations, combinations, none of that. Let's say they got a 12% on my test. They would be an outlier. 12%, that's an extremely low score. Extremely low score. Can anybody tell me what they would do to our class average, which is like an 82? What would they do if I threw in that 12%? What's that? Yeah, they would suck down our class average. It would be a really big bummer. Right now, you know, I think when you go into Progress Book and you view your progress in the class, you can see our class average. The unfortunate case is, like, I have a student in one of my classes who just has been really ill and hasn't been to school in like 2 weeks, has missed like 2 tests. And right now they have like a, you know, just nature of the course, we don't have a ton of grades. Right now they have like a 20%. So my class average is like so low because that one, you know, person still has a couple of tests to make up. So, you know, right now you look at the class average and you're like, oh my gosh, everybody in the world is struggling with this class. But really, it just is taking one person to be like, like suck down that class average. So it happens. I have one last real world example of this, and then I'll move on to actually doing the problems with you. Have you ever heard your teachers say, bless you. Have you ever heard your teachers say it's better to get some credit than no credit on a homework assignment or on a project? Have you heard that? Who's heard that? It's better to get some credit than no credit. Good, good. Well, that's an example of like the effect of an outlier. You folks are good students. This is an Honors Algebra 2 class. You people, you do your stuff. You get it done and you get it done well, right? Well, if you get a 0 on a homework assignment, that's an outlying score for your homework grade. So what does that do to your average? Really yanks on it pretty hard. So that's why it's always better to get something rather than nothing, especially for you folks. So you got to think about that too. All right, so now let's put the pencil to the paper, maybe do a problem or two. If you take a look here, we have a soccer team. I know I have some soccer people in here. The winning scores for the first 9 games of the soccer season are 3-4-2, 5-3-1, 4-3-2. You are going to enter those into your calculator. In part A, I want you to find the mean, median, mode, range, and standard deviation of that data set. Okay, I'm going to give you a second to do that to make sure that everybody in the room can make good use of their calculator. And then we'll go to the sticks. I want those answers. If you want to clear your list quickly, to clear your list, you go to Edit, and then you just make the L1 dark. Move my cursor up there, press Clear, and then the down button, and that will clear your list for you. You can also manage your lists in the memory of your calculator. You do have the option to clear all of your lists. Second mem, option 4, will also clear out lists that you have. So you do have a couple options as far as that's concerned. Your values there. Mean should have been 3. Median's 3. Mode is 3. Range is 4. Standard deviation, we use sigma x 1.154. If you use SX, that's fine too. Like I said, I won't be picky. All right, for part B, the winning score in the next game is an outlier. So when you throw 12 into your list, this is what you get. If you just add on 12, all of a sudden, wow, they scored 12 points. That's awesome. Look what it does to our mean. It took it from 3 to 3.9. This would be the equivalent of you typically being maybe like a DC student, and then all of a sudden you get 100% on a test. Because we've had so much data at this point, 100% could be considered an outlier. Median would be 3. Mode would be 3. Interesting. The range is 11, and the new standard deviation would be 2.9. The most important questions in the second half of today's lesson are actually C and D. So I need you to critically look at the red row of data and the blue row of data. Part C. Which measure of central tendency does the outlier affect the most? When it says central tendency, by the way, those are your 3 M's, mean, median, and mode. Which one did it affect the most? Go ahead, Izzy. Central tendency, mean, median, or mode. The mean was affected the most. You are correct. If you have a high outlier, it's going to yank that average up. If you have a really low outlier, it yanks it down. The least would have been our mode. And then central tendency or standard deviation, both were affected. These questions are revisited on your homework assignment for tonight, 11-1 Practice B. You're doing all of it, but on your calculator, not by hand. That would be miserable. You are doing it in your calculator. And we'll check for that on Monday. Hey, have a nice weekend. Stay warm. Grab your snow shovels.